Okay, so let's take a look here. Ooh, very nice colors you've chosen there. Okay, so the first one just straight up x is greater than 2/3. So you put a 2/3 on your number line. Greater than means it's going towards the right. It is also an open circle because there's no equal to sign on there. Number two, it's x is less than or equal to -3. So I put a -3 in there. I color in the -3 because it's equal to. Less than means getting smaller, going towards the left. Number three, -5 is less than or equal to x, which is less than 7/2. That's how I'd read that. And, well, it's an and. Ands look like segments. So I color in the first one, the -5, on the number line because it's equal to. Open circle around the other number, the bigger number, 7/2, because there's no equal to sign. Color it in between there. And then finally, number 4 is an or. I know those are going to go like this. Rays in opposite directions. And the first one is 1. It is an open circle pointing to the left. And then I have a 2. It's colored in, equal, and pointing to the right. Not too bad, not too bad. Okay, so notice that we haven't actually solved anything yet. We just graphed some, talked about them. So here's a question. How are the rules for solving linear equations, as in inequalities? Let me try that again. How are the rules for solving linear inequalities similar to or different from solving regular linear equations? Like, just if I take away the equal sign versus putting it in, like, how do those things work? Do I solve them the same way, or do I do something different? So for example, it says solve x plus 4x plus 3 is less than or equal to 6x minus 5. Now, I'm not asking you to solve it right now, but think about the steps that you would do in order to solve it. Do you do the exact same things as solving an equation? And yeah, you kind of do, but are there some things that are different? Okay, so look at that equation. So I might want to get the x's on one side of the inequality sign, right? So I would subtract either the 4x's from the left to the right, or I would subtract the 6x's from the right to the left. Okay, that's just like an equation. I would do the same thing with the 3 or the -5. Get it on one side of the equation. I get to do that just like a regular equation. That's exactly the same. That's how they're similar. Okay, so but what about, is there something that's different? Is there something that's different? Like, what if you were to, like, divide both sides by a number? Is there something you're supposed to do? Yeah, you're supposed to flip that sign, the inequality sign. Remember, if you multiply or you divide by a negative number. And that's a huge difference, right? You don't have to ever worry about that when it's negative. But when it's, when it's an equation, but when it's an inequality, you do. And I'm going to show you why that's the case in just a little bit. So that's the essential difference. And there's another difference, because we've talked about some compound inequalities. And compound inequalities, here you got two inequalities. Sometimes they're together, and so maybe there's more than one side there. So some similarities, you can add and subtract quantities from both sides of the things. You can multiply or divide by positive quantities, and it doesn't change anything. And then in either case, you expect a solution, right? Okay. So how they're different, though, is you can have more than one side. So think of those and inequalities, which look like this, like -4 is less than or equal to 2x plus 5 is less than 18, something like that, right? So you have more than one side. You got 3 pieces instead of just 2. And what are you supposed to do whenever you multiply or divide by a negative number? Flip your inequality sign. We'll see why in just a minute. And then inequalities, I'm not looking for just one solution. I usually have an infinite number of solutions. So let's actually solve this thing now, step by step, and then graph the solution set. Okay, so I've got 4x plus 3. Oh, let me just rewrite it, because I don't know why I set this up like this, because I can't write underneath it. 4x plus 3 less than or equal to 6x minus 5. Okay, I know that I need to get x's on one side, so you pick. You pick. I usually like to keep things on the left side. What about you? Like the variable? Okay. So maybe I subtract these 6x's over here. Now, see what I'm doing here? I don't ordinarily, you'll see me, if I'm solving equations in the classroom, or probably in here as we go through these videos, I'm probably not going to do those kind of steps. I'm going to do it in my head, and I would expect you to be comfortable enough with equations that you can do that too. So subtract this, I have negative 2x plus 3 is less than or equal to the negative 5. Okay, now I need to get the variable by itself still, so I get that 3 over to the right side by subtracting it, so minus 3. And when I do, I'd have 2x is less than or equal to negative 8. Negative 2x. And then I would divide both sides by negative 2. So when I divide by negative 2, I would get x is, and what am I supposed to do with that inequality sign? Flip it. Greater than or equal to 4. Okay, so there's the answer. And let's go ahead and graph it. It should be pretty easy to graph. That's what we were just talking about. I get a 0, I get a 4. It's equal to, so it gets a colored in circle. And it's greater than that, so I move over to the right. Okay, so let's just take a minute and just and talk about why you have to flip it. You probably remembered that you were supposed to flip it when you divide by a negative, but you probably don't know why. Nobody probably ever told you why. You probably didn't even care, but I'm gonna show you why in just a second. It's a very simple thing. It's very, very simple. What if instead of subtracting if I go back to the first step of the equation right here, let me just change colors here so it makes it more obvious. I'll make it red. Okay, instead of subtracting the 6x, what if I subtracted the 4x? Okay, so instead I would have, well, I'll just put it here. I'll just make this minus 4x here and minus 4x. Instead, on both sides, so I'd have 3 is less than or equal to a positive 2x minus 5. Then I'd get the 5 over by adding it this time, plus 5 and plus 5. And I'd have 8 is less than or equal to 2x. Do you see where this is going? See where this is going? It's because of where the x is. It's because of where the x is. I'm going to have to divide by the 2, and I have x. From the x's point of view, that's a greater than sign. From the 8's point of view, it's less than. But anyway, so if I look at this one, negative 2x is less than or equal to negative 8. If I were trying to keep things positive, I could add this over here. So add the 2x over, and I could add the 8 over to the other side, and that essentially flips the two things around. So add the 8 over here and the 8 over here, and it switches them around so that I have this statement. So it gets it backwards. And it seems like so much to do that you don't think about it, and math teachers always say, oh, instead, don't worry about that. What you do when it's negative, and I'm dividing by a negative or multiplying by a negative, just flip it, and then you don't have to worry about it. There you go. Okay. Well, that's the end of that first objective. I hope you enjoyed it. Stay tuned for the second one.